fixed point iteration method. Okay, isa to sa mga open method sa numerical method sa root finding using yung fixed point theory in algebra. Anong ibig sabihin nun? So, let's say I have x which is equal to a function g of x. Ang sinasabi lang nito, no, ito yung input ko, whatever is my input value, yung x, equal doon sa output ko. This is what we refer to as a fixed point. Now, sa fixed point iteration method, napakasimple lang ng gagawin natin. I-express lang natin yung function natin sa ganitong form. Kasi sa fixed point iteration method, no, yung new value ng x ko is equal doon sa value ng g of old x. Okay? So, gawa tayo ng example to illustrate this method, tong fixed point iteration method. So, here is an example. So, balikan natin tong quadratic equation na to. And of course, since quadratic siya, dalawa yung sagot, no? Meron tayong positive at saka negative root or 0. Now, using fixed point iteration, the first step is to express our equation na nasa left-hand side si x equals some function g of x. Okay? Ganyan muna yung first step natin. So, para dito, pwede kong gawin, I can move 1 doon sa kabila. So, let's say x squared minus x equals 1. And then, i-factor ko to. This is x, saka x minus 1 equals 1. Okay? Then, x is equal to 1 over x minus 1. So, ito na yung x, then ito yung g of x ko. Yung g of x ko yung 1 over x minus 1. Sulat natin yan dito sa taas. Ang mangyayari lang, no, yung new value ng x ko equal doon sa 1 over old value ng x minus 1. So, mag-substitute ka lang na mag-substitute ng number. So, let's say for the first iteration, let's say our value of x is 0. Yan, kuwari 0. So, ano yung value ng g of x ko? Yung g of x is itong part na to. Ito yung g of x. So, 1 over 0 minus 1, syempre negative 1 yung lalabas. And for the next iteration, ano yung value ng g of x? Yun na yung bagong x na gagamitin ko. Then, isa-substitute ko ulit doon sa g of x. So, 1 over negative 1 minus 1. Syempre, ang lalabas na answer is negative 1/2 or negative 0.5. Then, I will continue, no? So, third iteration, negative 0.5 na yung bagong x. And, isa-substitute ko ulit siya doon sa g of x. So, 1 over negative 0.5 minus 1. And you will get negative 0.667. Yan, uulitin mo lang siya nang uulitin. And, eventually, you will get a value for g of x negative 0.618. So, ito na yung magiging value nung x natin. So, nakuha natin yung negative root. Okay? Sa fixed point iteration, dependent doon sa makukuha nating equation or itong equation na to na x equals g of x, yung makukuha nating root. So, ito, no, kapag ginamit mo tong equation na to, ang makukuha natin is the negative root, negative 0.618. So, let's try another way of expressing our equation doon sa form na x equals gx. Ang gawin ko, ilipat ko yung x minus 1 sa kabila. So, magiging x squared equals x plus 1. And then, I will divide both sides by x. So, matitira dito x is equal to pag ginawa mo to, this is 1 plus 1 over x. O, lagay natin yan sa taas. At ito na yung magiging fixed point at iteration equation natin. So, the new value of x, kung makikita mo dito, x na siya. Tapos dito sa right-hand side ng equation natin, ito yung parang g of x natin. So, imbis na x, so this is the old value of x. So, gagawin ulit natin yung iteration natin. Let's say, first iteration, x, siyempre, hindi natin gagawing 0 yung unang hula natin. Manghula ka, let's say 1, kasi kapag 0, 1 over 0, wala na yun. So, yung g of x natin, so 1, pag sinubstitute mo dito, magiging value ay 2. For the second iteration, Yung g of x, yun yung magiging value of x natin. Pag sinubstitute mo yan doon, ang makukuha mo, 1.5. Then, for the third iteration, 1.5 na yung bagong value ng x. And g of x will come out as 1.667. Fourth iteration. So, continuous lang natin gagawin. And hanggang mag-arrive tayo na yung value ng g of x or yung x natin, makuha natin 1.61. Using another form ng equation na naka x equals g of x, makuha natin yung isang root. Now, dito sa equation na to, ang pinaka-obvious way na para maging x equals g of x siya is ilipat mo lang yung x sa kabila, no? Parang magiging x squared minus 1 equals x, or x is equal to x squared minus 1. So, yung form niya is, ganun na yung form, no? X is equal to any function of x. X equals g of x. No, kung mapapansin nyo, bakit kaya hindi ito yung inuna kong gawin? Kasi yun yung pinakamadali, di ba? Ilipat mo lang isang x, ganun na yung form niya. If we use this form kasi, no, i-try natin, no? Let's say x is equal to 1. Pag yan yung ginawa mong form, so ang mangyayari, yung g of x mo, so substitute 1 dito, so 1 minus 1 is 0. Second iteration, 0. Pag sinubstitute mo yung 0 sa x, so 0 squared is 0 minus 1, negative 1. So, negative 1. Pag sinubstitute mo dito is 0. 0, negative 1, and so on. Paulit-ulit yung value ng x natin. Wala tayong nakakuhang number na constant. No? Ang tawag dito, hindi siya nagko-converge. Nagda-diverge siya yung equation na to. So, ibig sabihin pala, sa fixed point iteration method, dependent yung method na to sa how you will express the equation in this form. Kasi iba yung magiging makuha mong sagot, no? Makuha mo either yung ibang roots or maaaring hindi siya mag-converge. So, itong dalawang to, tinatawag nating convergent o converge. Itong isang to, yung x equals x squared minus 1, this is divergent. So, sa fixed point iteration, merong ganong issue. Actually, sa mga open methods, no, lahat sila dahil wala kang bracket, wala kang limits, maaari silang may chance na mag-diverge. Let's investigate that, no? Paano ba bakit nangyayari yon? Yung fixed point iteration, bakit siya nagda-diverge? So, I have here yung x at saka gx. At ito, in-express ko lang sila as separate functions. So, y equals x to, ito y equals gx. Kailan sila mag-i-equal? Siyempre, doon sa kung kailan sila magi-intersect yung dalawang graph natin. At yung intersection na yan, yung x coordinate ng intersection na yan, that is actually the root of our equation para doon sa x equals g of x. For this case, so ganito kasi yung ginagawa nating method graphically doon sa fixed point iteration. So, nanguhula tayo ng value ng x. Let's say dito, no? Manguhula akong value ng x. This is x sub 0. Isa-substitute ko siya sa g of x. Ito yung g of x. At yan ang magiging value ng y equals x ko. So, this will be the new value. So, ito yung magiging x sub 1, yung second iteration. And then, again, isa-substitute ko siya doon sa blue. Yan ang magiging value ng x second iteration, and so on. So, kung mapapansin mo, papunta doon sa root yung fixed point iteration ko. This is the graphical representation of that. Now, in this case naman, so ito yung convergent, no? Ito yung convergent. Nagko-converge yung function na to. In this case naman, makikita mo anong pagkakaiba nila. So, mamaya pag-usapan natin pagkakaiba. Pero pag ginawa natin yung method na yon, kuwari, nanghula ako dito. Let's say, malapit na sa root. Yung hula ko, yung unang x value, x sub 0. So, isa-substitute ko siya doon sa g of x. Yun yung magiging value ng x. And kung ano man yung value na yon, that will be my second or my first iteration na x. And then, sa-substitute mo siya g of x, kuha sa x, and so on. Kung mapapansin mo, yung motion niya, palayo doon sa root natin, which is the intersection of y equals x saka y equals gx. So, ito yung case kung saan nagiging divergent yung ating fixed point iteration. Now, paano yon? Bakit nagkakaroon ng convergent at saka divergent? And this is actually true for all open methods. Merong convergent, merong divergent. So, let us analyze yung convergence. Ito, mag-analyze tayo. Derive natin bakit may ganun. So, suppose, di ba, ang equation natin, x equals g of x. Suppose r is the root. So, r is equal to g of r. R is the root of our equation. Okay? Yung error ng isang iteration or the absolute error is actually kung ano man yung value ng x na makukuha mo minus yung real root natin. Naka-absolute value kasi wala tayong pakialam kung positive o negative. So, this is the error. Gaano siya kalayo? No? Ito yung guess value of x natin. Ito yung real root. Okay? So, gaano siya kalayo? Siyempre, subtract mo lang. Kung ang root mo ay 1, tapos ang guess mo is 5, so ang error mo, 4. Diba? 4. Okay. Our iteration, it's actually xi plus 1. Kaya may plus 1 kasi new value ng x is equal to gx of I. Ganon, diba? And yung next error, yung error nung susunod, I plus 1, is yung value ng x sa iteration na yon, so nag plus 1 ka rin dito, minus syempre yung root. But, again, nakikita mo, yung xi plus 1 is equal dito, at yung r, yung root, is equal sa g of r. So, yung error at the next iteration is equal to the absolute value ng g of x sub I minus g of r. Okay. So, ito yung error natin nung next error in terms of the functions gxi minus gr. Now, sa calculus, meron tayong tinatawag na intermediate value theorem. Ang sinasabi lang nito, if meron kang function at yung derivative niya ay nag-e-exist, merong derivative, pwede mong i-derivative yung function na yon sa limits a hanggang b, merong point c sa gitna ng a, b, such that this expression is true, such that yung derivative ng function at point c is actually equal doon sa function at point a minus function at point b over a minus b. Now, rearranging this, ang makukuha mo is the function at a minus the function at b is equal to the derivative at c times a minus b. Yung function a minus function b, pwede nating i-substitute tong values na to. Okay? Pwede nating i-substitute yung values na yan. So, we have the error at I plus 1 is equal to the derivative of g at some point c times a minus b, which is yung x sub I minus r. At yung x sub I minus r na yan, di ba? Yan yung error nung previous iteration. So, ang sinasabi lang nito is related yung next error by the derivative ng function natin at point c. At point c is a point in between xi and r. Okay? So, derivative na to times yung previous error. So, ito yan. Now, ano ang pwede nating i-conclude? Ano ang pwede nating i-conclude dito sa analysis na to? Pwede nating i-conclude ganito. So, may error ako. Gusto ko, sa next iteration, of course, gusto ko, mas malaki ba o mas maliit yung error? Gusto ko lumiit yung error. So, paano liliit yung next na error? Mangyayari yon kapag itong derivative na to is, yung derivative na yan is less than 1. para yung kung anumang error na to, mata-times siya sa a number less than 1. So, the next error will be smaller. Kasi kapag yung error ko or yung derivative ko is greater than 1, let's say 2. So, kung ano man yung error nung previous, pag tinimes mo ng 2, lalaki siya ng lalaki. So, ito ang magiging criteria natin. Pag ganito, no, pag less than 1 yung derivative at that point, this will converge. Kasi liliit ng liliit yung error. Yung kabila naman, this will diverge dahil lalaki ng lalaki yung error. At yung C, tandaan no, dito sa ano natin, C is in between AB. So, C is a number in between xi, yung hula mong x, at saka yung real root. Okay. So, example, para dun sa kanina, no? Ito yung mga expressions natin for x equals gx. So, for number 1, yung gx ko is 1 plus 1 over x. Pag kinuha ko yung derivative niyan, it will become negative 1 over x squared. Pag nag-substitute ako ng value sa x, let's say in the range 0 to 1, so any number in between, ano ba yung any number in between? Let's say 0.5. So, g prime of x equals negative 1 over 0.5 squared. This becomes 4. So, ma-assure ko na kapag ito yung sinubstitute ko dito, hindi ako makakuha ng convergent value pag between 0 and 1. Diba? Actually, ito yung mag-give nung value na 1.618. So, siguro, try natin between 1 and 2. Between 1 and 2. Dahil alam naman natin na yung root is 1.618. So, kung between 1 and 2, pag ang sinubstitute mo dyan ay 1.5, let's say 1.5 squared, of course, ang makuha mo is 0.44, which is less than 1. Kaya, kung between 1 and 2 ang root, at ginamit mo tong expression na to doon sa fixed point iteration method natin, you are assured na mag-converge siya dahil less than 1 yung value nung derivative niya at the points between this 1 and 2. Okay? Mag-converge siya. Dito naman, alam natin na ang root na makuha natin dito is 0.618. So, let's say between negative 1 and 0, mag-converge kaya siya. So, substitute mo yung value dito sa derivative. So, negative x minus 1 squared. So, yung x ay gawin nating negative, let's say negative 0.5. So, again, g of x is negative to, is negative 0.44 at by the way, naka-absolute value nga pala, no? Baka makalimutan. This should be naka-absolute value. Dahil may absolute value to. Okay? Absolute values. And again, the magnitude is less than 1. So we are assured na magko-converge itong expression na to into the given root. For the third one, yung mas madaling expression na nilipat ko lang yung x, may kita mo yung aking g prime of x. Pag sinubstitute ko dyan is 1, magiging 2, so greater than 1. So, kailan lang to magiging less than 1? Magiging less than 1 lang to if the value is between negative 0.5 at saka positive 0.5. So, ayan, magko-converge siya kapag yung limits ko is from negative 0.5 hanggang positive 0.5. Doon lang siya magiging less than 1. Ito lang yung magiging less than 1 siya. Pero, ang makikita mo, pag sinubstitute mo yung kahit anong values dito doon sa ating equation, wari yung 0.5 sinubstitute mo doon, ang lalabas is negative 0.75, which is wala na dito sa range of limits na to. So, pag 0.75 na siya, magda-diverge na siya. So, kaya ito naging divergence. Kasi yung mga values na isa-substitute mo dito, lumalabas is greater than 1. I-try naman natin sa Excel kung paano yung fixed point iteration. So, meron ako ditong function. Ito ay e raised to negative x minus x equals 0. So, yung mga nakarang example, yan yung equation na ginamit ko. So, I am to find the root using fixed point iteration. So, ang ginawa ko, no? I-express natin in terms of x equals gx. So, ang ginawa ko, x is equal to e raised to negative x. Okay, so ito yung table natin. So, first iteration, value of x. So, g of x ko is e raised to negative x. So, exp raised to negative nung value nung x. And for the second iteration, yung new value of x ko ay equal doon sa g of x nung previous. Tapos, ida-drag down ko lang to. Yan. Now, I have here another column called relative error. At ito yung equation for the relative error. Ang gagawin ko lang, no? This should be x. Paano kunin yung relative error? This is equal to the absolute value nung difference nung new x at saka nung previous x divided by yung new x. Relative error ko, ibig sabihin malaki. Ibig sabihin, yung current x ko at saka yung previous x ko, hindi pa masyadong nagko-converge. Ganun. And then I will drag this down at may kita mo, habang dumadami yung iterations, bumababa yung relative error up to a point na halos wala ng error. So, after, let's say, 20 iterations, the value of x is 0.56714. So, ganyan gumawa ng fixed point iteration using Excel. So, let's have another example. Ito yung example kanina. Ang gagamitin kong g of x is yung 1 plus 1 over x sub i. So, this should be equal to 1 plus 1 over the value of x. And this is equal to the number of iterations. Yung current value ng x is equal to the previous value ng g of x. And then, drag down. Relative error is the absolute value ng current minus previous x over current value of x. Malaki pa yung relative error. After some iterations, let's say, ayan, 10 iterations, I will get the value of x is yung 1.618. So, 0.03% na lang yung relative error after 10. Let's have another fixed point iteration example sa Excel. Isa namang form, yung 1 over x minus 1. So, g of x ko is 1 over value ng x minus 1. So, may kita mo dito, division by 0. Kasi 1 yung sinubstitute ko. So, palitan natin yung value natin. Let's say 0.5. Yan. Okay? Automatic naman yan. So, yung next value ng x is equal doon sa previous value ng g of x. Is, increment lang natin, number of iterations. So, again, drag down yung equation. Relative error. Okay natin. Then, let's say, let's have 10 iterations. So, after 10 iterations, makuha ko na yung isang root which is yung negative 0.61842. So on. So, sa Excel, no, pwede mo i-drag down yan ng kahit ilan hanggang mag-zero yung relative error and you will get yung mas accurate na result.
Like mo yung video kung ayos. Pag hindi, pag mo i-dislike, leave ka ng comment kung bakit, ha? Sige na, subscribe.